All right, so the last thing that I want to talk about on these notes, there's one special case that you're going to see often that we didn't talk about last year in Honors Chem when you're dealing with empirical formulas, and that's called combustion analysis, okay? And they just like to throw this one in here for a little bit of a curveball on the empirical formulas. And it's not that bad, you just have to know the process, okay? So a lot of times when you have a carbon, hydrogen, and oxygen compound, then you can analyze it by essentially burning it and separating the carbon, the hydrogen, and the oxygen. Okay, or actually, what you really separate here is you separate the H2O and the CO2 from one another. And once you know how much H2O and CO2 there are, you can usually figure out what the sample is. Okay, so that's the reason for this type of thing. But basically, the way that this works, I just want to show you how to do this example problem here. Let's say you've got isopropyl alcohol, and that's also called rubbing alcohol, and it's got carbon, hydrogen, and oxygen in it. Okay, and we do this combustion analysis, and we've got 0.255 grams to start out with. Okay, and then it produces 0.561 grams of CO2 and 0.306 grams of H2O. We want to know what the empirical formula of the isopropyl alcohol is. Okay, now the way that this works, keeps doing that. What we have to remember here is what's going on. Okay, we've got some sort of carbon, hydrogen, oxygen compound, CXHYOZ, something like that, and we're combining that with oxygen, burning it, and making CO2 and H2O. Okay, so what we have to realize here is that the only place that the carbon is going when it gets burned in this compound is into the CO2. Okay, and the only place the hydrogen is going is into the H2O. And so basically we can figure this thing out because we can figure out the carbon, we can figure out the hydrogen, and then by process of elimination, because they gave us the total mass that we started with, we can also figure out how much oxygen we have. Okay, so that's what we're going to have to figure out here. So basically we've got 0.561 grams of CO2. Okay, so 0.561 grams of CO2. And we want to know basically what mass of carbon did we start with here, if this is how many grams of CO2 that we end up making. Okay, so what we're going to have to do is we're going to have to do a mole ratio here. Okay, so we know that in 1 mole of CO2 we've got about 44 grams of CO2. Okay, so that tells us how many moles of CO2 that we have. Then we want to go from moles of CO2 to moles of carbon. Okay, and basically we talked about this yesterday. Okay, so this is a place where this comes into play again. If we have 1 mole of carbon dioxide, for every 1 mole of carbon dioxide we have 1 mole of carbon as well. Okay, then we can go from there back to grams of carbon. Okay, and we can figure out how many grams of carbon we have in this thing. There are 12 grams in every 1 mole. Okay, so once we do all of that, cancel everything out, make your respective noises when you cancel. We're going to end up with 561 0.153 grams of carbon. Okay, so that tells us the mass of the carbon. That's good. We're kind of halfway there. Then we can look at the mass of the H2O that we make here, 0.306 grams of H2O, and we got to do the same thing again. Okay, so we've got grams of H2O. We want to see how many moles of H2O we have here, because what we're trying to figure out from this grams of H2O, we're trying to figure out how many grams of hydrogen that we have. Okay, so in 1 mole of H2O there's 18 grams. All right, and for every mole of H2O that we have, we're going to have 2 moles of hydrogen because the formula is H2O. Okay? And then once we know the number of moles of hydrogen, then we can go back to grams of hydrogen and we can figure this out. And that's basically a 1-to-1 there. So then we've got 0.306 divided by 18 times 2, 0.034 grams of hydrogen. All right? So that tells us the grams of the carbon, the grams of the hydrogen that we have. Let's see if I can go down any further here. Okay, good. It's letting me. Now, what you have to do is you have to look up at the beginning of the problem because we also have some oxygen in this compound. This is a compound that contains carbon, hydrogen, and oxygen, right? And so what we have to figure out here is how much oxygen do we have? But that's not difficult because we know how much carbon and how much hydrogen we have, okay? The total isopropyl alcohol that we combusted was 0.255 grams. Sorry about that. 0.255 grams of the isopropyl alcohol. Okay, that's the total. Now, if we subtract the carbon and the hydrogen from that, 0.153 plus 0.034, that's going to give us our mass of our oxygen. Okay. So that's going to give us 0.068 grams of oxygen. Let me double check that just to make sure I did that right. Yeah, 0.068 grams of oxygen. Okay. So now we have the mass of all 3 of our things that make up the isopropyl alcohol. Okay. And so now it becomes just a normal empirical formula problem, and all you have to do is just, you know, we've already got our masses here, so we just change these mass to mole. Run out of room here. In 1 mole we've got 12 grams of carbon. In 1 mole we have 1 gram of hydrogen. And in 1 mole we have 16 grams of oxygen. So then when we work all this out, these are moles. Oh boy. Okay, so our smallest number is the oxygen at the bottom, 0.00425. And so we're going to divide by the smallest here. See if I've got any more room. Okay, I do. Let's see what we end up with here. Getting 3 for the carbon. Getting 8 for the hydrogen. This is working out well. And 1 for the oxygen. Okay, so our empirical formula here, which actually ends up being our molecular formula as well, C3H8O. Okay? And so that's how you do that. Hopefully that makes sense. We'll do another one of those combustion practices in class because those are a little bit tricky. But the main thing you got to remember here is they're going to give you the mass, they're going to give you the mass of the CO2 and the H2O. Instead of giving you the mass of the carbon and the hydrogen, you have to use this process right here to find the mass of the carbon and the hydrogen. Okay? And then from there you can usually find the mass of the oxygen, and then it's just like a normal empirical formula problem. Okay, that's pretty much it for today. Hopefully that makes sense, and we'll do a lot of practice on this tomorrow in class.